Hello students. Today we start a new topic in a module number 5 special work. So in module number 5 today we start a new topic name is scaffolding. So here what is scaffolding? So generally scaffolding we use as a temporary structure. So here definition of the scaffolding is given, a temporary structure from which person can gain access to place in a order to carry out building operation. So here like a temporary frame usually constructed from a steel or aluminum alloy tubes clipped or coupled together to provide means to access of a high level working area as well as provide as a safe platform from which to work. So here generally scaffolding is we use for the construction work like plaster work, then after also we use for the masonry work and also for the concreting work. So all the types of the work we use the scaffolding, and here some of the function of the scaffolding is given. So as a working platform, so scaffolding is one type of the working platform so that the worker can stand on a platform and do work easily and safely, so without any accident worker can done all the works easily and safely. So here also second function of the scaffolding is a platform for placing of material, logistics and needed by worker to carry out their jobs, and as a platform and a working passage, scaffolding support the platform that being used by the worker as their walking path to transport the material and logistic. And here generally scaffolding we use as a steel scaffolding or iron scaffolding or timber scaffolding is generally used in a construction industries. Now here some of the factor needed for the scaffold is uh, first is easy to erect, so it's easy to erect, and if after completion of the work, so it's easy to dismantle. Now next is strong, because this scaffold is not a use for the single time, it's used for the multiple time, so scaffolding is strong enough. And uh, also sometime scaffold is weak, so accident is generated by the accident is generated. And third one is a light in weight. So why scaffolding is light in weight? Because it's easy for the transportation, like if one site is completed, so for another site transportation of the scaffolding is required, so this if light in weight, so it's easy for the transportation. Now fourth one is a safe. Now in a safety, scaffolding is compulsory required for the safe purpose, so it's prepared by the good material. So if the material is good, we use the good material, so it's not eroded or not damage in a small time, so it's safe for the person who use the scaffold. And for fifth one is suitable. So at a suitable place, scaffolding, different type of the scaffolding we use, so it's as per the suitability we use the different scaffold. Next is the passage connecting to other place. So here if the two scaffold are stand at a same place, and between the two scaffold uh, joined by the passage, so this passage is connecting to platform or with each other by the platform, because for the uh, it's easy for the person to move one platform to another platform. Now next is a scaffold can be made from the following materials. So here some of the three types of the material is generally used. First is a tabular steel, second one is a tabular aluminum alloy, and third one uses a timber. Now steel scaffolding, so steel tube are nearly 3 times heavier than the aluminum alloy tubes, but as far as stronger, because steel is stronger as compared to aluminum, and for a longer span can be used since it deflect in approximately 1 by 3rd part of the aluminum alloy tubes. And there are two types, is first is a galvanized steel tube, and second is a ungalvanized steel tube. So here that needed special care like painting, varnishing, or oil bath after use. So here ungalvanized steel is maintenance cost is higher as compared to galvanized steel tube. Now here see this figure. These figures show the uh, steel scaffolding. So here steel scaffolding after using color is required, and here if we use this coating material in a scaffolding, so no any type of the color is required. And one of the disadvantage is that so it's eroded in a small time, because in a construction water is using in and water is erodes the steel structure. Now second type of the scaffolding is aluminum scaffolding. So need protective treatment when they are to be used in a contact with a material such as a damp line, wet cement, and seawater to prevent the corrosion to tube. So aluminum scaffolding is not corrodes easily, so this type of the scaffolding is used. And coating the tube with a bituminous paint before using it would be suitable protective treatment. Now here see this figure. So this type of the platform is made by the aluminum section, so it's light in a weight and not corrodes easily, because in a construction weight cement and water is affect the steel structure, but in a aluminum structure this type of the problem is not created. So this type of the platform is made by the aluminum section. Now third one type of the scaffolding is a timber scaffolding. So extensively used in a developing country, and generally timber scaffolding is generally used because it is easily available. Second is cost of the timber scaffolding is less as compared to aluminum and steel section, and members are lashed together with a wire or rope instead of the coupling fitting use the metal scaffolding. So here see this figure in a timber scaffolding. Generally we use the bamboo or wood as a scaffolding, and this type of the scaffolding is maximum up to 10 to 15 story. We use this type of the wooden or a timber scaffolding. Now next is scaffold elements. So here different scaffold elements are generally uh, we seen. So like first one is a stands or a tiang, and then after second is a double coupler, so panganding, uh, back Berkmar bar, and swivel coupler. Third one is a fourth one is a putlock coupler. Fifth one is a base plate, and sixth one is a split joint pin, and seventh is a revel pin, and eighth one is a putlog end. So these are the different elements of the scaffold. So here stand is a vertical uh, component of the scaffolding. So it's generally in a large in a length, and see this figure number 2. So it's generally 1 to 2 story height. Stand is 1 to 2 story height. Second is the double coupler. So only the real load bearing fitting used in a scaffolding used to joint ledger two stands, and if the two pipes are joint or with each other, so double coupler is used. And next is a swivel coupler, so composed of the two single coupler riveted together so that it is possible to rotate them and use them for connecting two scaffold tubes at any angle. So here these two pipes are joined with each other at any angle, so it's rotate easily, and this coupler is joint two pipes with each other. Next is put lock coupler, so use solely for fixing the put lock or transom to a horizontal ledger. Now next is a base plate, so it is the fix at the bottom of the uh, stands, and it is used to distribute the load from the foot of a stand to sole plate or a firm ground. Next is a split joint pin, so a connection fitting use as you seen in a figure. So it's if two pipes are joined with each other, so this type of the split joint pin is used, and a connection fitting used to a joint scaffold tube end to end, and a center bolt expand the two segment that grip on the bore of the tubes. And next is a ravel pin, so fits into the end of a tube to form adjustable strut. So here these type of the ravel pin are adjustable, and last one is a put log end, so a flat plate that fits at the end of the scaffold tube to convert into put log. So put log is a simple wooden plates. Now next important topic is soaring. So in a soaring, first we discuss about what is soaring. Soaring is a provision of a support system for a trench phase used to prevent the movement of the soil underground, utilities, roadway and foundation. Now soaring is used when the location or depth of the cut makes slope back to the maximum allowable slope impractical. So installation of the soaring, so for a soaring timber or steel tube may be used, and sometime both are used in a combination. Now if the timber is used, its surface should be coated with preservatives so as to protect against the wet rot, and the soaring should be designed based on the load it has to sustain and duration of the load. Now shoring may give the internally or externally depending on a case, and in certain cases they may be provided on either side of the wall to produce additional stability, and shoring should be installed only after getting the permission if necessary of the local authority, and there is no time limit to which shoring has to be kept. It range from weeks years depending on a case. So here three types of the shoring we discuss in a lecture. So first one is a racking shoring, or racking shore or inclined shore. Second is a fly or horizontal shoring. Third one is a dead or vertical shoring. So racking or inclined shore. So in this method, inclined member known as a rackers are used to give a internal support of the wall, and rackers are to be inclined in a ground at a 45 degrees. So in this figure, yellow color rackers see exactly to support the wall, and it fixed at between the 45 degree to 75 degree angle, and for tall building length of the racker can be reduced by introducing the right racker. Now racker should be properly brushed at an interval, and the size of the rackers is to be decided on the basis of anticipated thrust from the wall, and the center line of a racker and a wall should be met at a floor level, and shoring may be spaced at a 3 to 4.5 meter spacing to cover long length of a bar, and the solo plates should be properly embedded into the ground, and inclination should be properly uh, section and size, and wedges should be used to solo plate, and since they are likely to give under vibration and that are likely to occur, and the sets of swords should be usually placed at a 3 to 46 meter and center to center along the wall length ranking sword. Now Next type of the shoring is the fly shore or horizontal shore. So it's in this type of the horizontal support are provided for the supporting the temporarily the parallel wall of the two adjacent building, which may tend to collapse or damage when one the immediately building has to be pulled down. So here two support is provided. Uh, it's called a horizontal shoring. So here single flying shore consists of a two wall plates, strut standing piece, horizontal shore, needles, cleats and wedges. So these are the elements of single fly shoring. And racking shore in this system also the wall plates are secured against the wall by means of needles and cleats, and the horizontal shore is held in a position by wedges. The needle and cleat to the wall plate. The inclined strut are supported by the needles at their one end, and standing seal at the other end. So here the following points are some of the point are kept in mind by use the flying shore. So the center line of the flying shore and the strut and the flying shore and a wall should be meet at a floor level. Second point is that if the floor level of two buildings are different or their strength are different, then shore position should be provided. And third point is that the maximum distance about the 10 meter between the parallel wall can be supported by a single fly shore. Now next fourth point is for a distance more than 10 meter, double flying shore having a trusted uh, from work is employed. And fifth point is that the flying shore are kept in a position so long as the adjacent building are made stable by the constructing the building sufficient height. And sixth point is that unlike and racking shore, shoring is this type, only one side of the shoring is employed to strengthen uh, the two adjacent wall, and the larger factor of a safety should be adopted in design analysis of flying shore because uncertainty of actual load. Now next type of the shoring is a dead or vertical shore. So this is the system of the shoring which is used to render vertical support to the walls and roof floor etc. And when the lower part of the wall has been removed for this purpose of providing an opening in the wall or rebuilding a defective load bearing wall in a structure. So the dead shore consists of an arrangement of a beam and a post which are required to support the weight of the structure above and transfer for the same. So here also in a dead support or dead shoring, see this figure, in this figure you exactly seen support is provided in a wall. Now when the opening in the wall are to be made, hole are cut in the wall at such a height as follow sufficient space for insertion of a beam or a gutter that will be provided permanently to carry out the weight above the structure, weight of the structure above. And distance at which hole are cut depend on the type of masonry, and it's varies from 1.2 meter to 1.8 meter center. And beams called a needle are placed in the holes are supported by vertical props called a dead shore and at their end either on a side of the wall. And the needle may be of a timber or a steel and are sufficient section to carry the load above. And a dead shore stand away from a wall on either side so as to allow for a working space when the needle are props are in position. And the props are tightened by uh, tightened up by folding wedges provided at their bases, while the junction between the props and needles is secured uh, with the help of dogs. And before dismantling the work is started, all the doors and window and other openings are well strutted in order to relieve the wall of the load of a floor or roof above they are independently supported. and vibration and shock are bound to occur when the wall cutting is done. As such, a measure of safety wrecking shore are sometimes erected before commencement of a wall cutting operation. So here shoring is finished. Now in a next lecture we discuss about the another topic. Thank you.